Hello everyone, welcome to the fourth lesson on differentiation. Uh, we have already given two classes for chain rule. I hope you've understood the process of chain rule. It is very important for further sums that we do. Now, before I start next type of differentiation, I would like to discuss some properties of logarithms which you are already aware of. So the first property is the product law. So how does the product law work in logarithm? We have done this in class 9 if you remember. When you have log a into b, mind it, when the subject is being multiplied, check this, when a and b are being multiplied, the subject, then we can write it as log a plus log b. Remember, this is not correct. I'm writing it here. Log a into log b is not equals to log a plus log b. Remember this one. Some misconceptions you may have. This is absolutely wrong. Or you may not say log a plus b is also never equals to log a plus log b. Remember, these things also you have to understand properly. These aren't going to work, the ones I have just written. Okay, so the one that will work is when the subject is being multiplied. Here you can say when the subject of logarithm is being multiplied, a into b, then we can split it as log a plus log b. Okay, the other property is the quotient law. Again, the same thing, you have a single log and a, b are being divided, you can write it as log a minus log b. Let me write the misconception. Log a divided by log b, some of you think this is equals to log a minus log b. This is absolutely wrong. This is not going to happen. Okay, so whenever this thing is there, you can't split it as a minus b, correct? Or else you may not say log a minus b is also equals to log a minus log b. No, that is also wrong. Remember, log doesn't get inserted inside and distribute over minus or plus. This is never going to happen. There is no formula for log a by b. There is no formula for log a minus b. Okay, so you can only write it as if the a and b are being multiplied together, you can split it as log a plus separate log b. Or if a and b are being divided, then you can split it as log a minus log b. Okay, you can see that here there is a single log, whereas whenever it becomes plus and minus, the log gets distributed, correct? Okay, and finally the third one, the power law. The power law says if you have log a to the power b, then we can write it as b log a. That means if you ever have a power, example log 2 to the power 5, if you have, then we can write it as 5 log 2. Okay, the power comes to the coefficient. Remember this, correct? Okay, by the way, I haven't written the base for all this logarithm. The basis for all this logarithm right now, you may say it is 10, because standard logarithm the base is how much, everyone? 10 base. Okay, but in calculus, all the logarithms that we have, the base will be considered as e. Okay, what is the base, everyone? E. So in logarithm, you also know this, if the base and the subject is same, what will happen if you have log a to the base a, then we can write it as 1. Similarly, log e to the base e is also considered as 1. Remember these two also. Okay, so you may copy this as well, 4 and 5, correct? I want you to copy this, pause the video and copy all this property in your notebook. It is a very important property. Okay, I will discuss one more property of logarithm that will come later, that is called change of base. Once we have understood logarithms, now we can go to the first type of differentiation, that is called the logarithmic differentiation. So let's read what happens, or when do we use this type of differentiation. So it says it is used under the following situations. Number 1, when a function is a product or quotient of two or more other functions. So let's have a look. I'll give you an example. By the way, I want you to copy this theory in your notebook. So these 2 points, please copy it till here, from here to here. Okay, you just note it down in your formula copy or notebook. Let's have an example. So the first one, when the function is a product of many functions, maybe suppose y equals to x plus 1 to the power 5 and x plus 2 to the power 9. If you have this, then you know how to differentiate this. You could have differentiated this by using product rule as well. Okay, but the easier way would be when we use log both sides. If you take logarithms both sides, then what will happen is you take log both sides, then x plus 1 to the power 5, x plus 2 to the power 9. If this happens, you know the multiplication, when subjects are being multiplied, I can use the property. What is the property, everyone? This looks like log a into b, so I can say log a plus log b. Can I not write like this, everyone? Because the subject are being multiplied. You know the product rule of logarithm. Then the power comes front, 5 log x plus 1, and then I can also say sorry, there was a 9 comes front, so log x plus 2. Now isn't this easier to differentiate than the first one? So remember, using logarithmic differentiation, or using log both sides I may say, will help you to differentiate in a easier way. Okay, so that is the basic thing, the basic rule here. So that's why we use logarithmic differentiation in these two cases. And number one I have already discussed, when the function is a product or quotient. By the way, I can show you quotient also, even if you have quotient. So if you have x plus 2 x plus 1, just an example, instead of using quotient rule you can use logarithm and simplify also, because if you take log here, what is going to happen, log y will be equal to log x plus 2 minus log x plus 1, because division means minus in logarithm, isn't it? So you may not use this for simple quotient and product rule. Okay, so we also have quotient rule and product rule for solving for differentiating functions. But if the quotient and product is quite long and quite complicated, then you may use it. For example, y equals to under root x plus 1 x plus 5 divided by 2x plus 1 to the power 6 and x minus 1. If you have such fraction, then you may use logarithm and try to simplify it, because this, instead of square root, I can make a half power, and then I can use logarithm and simplify, and then it will be quite simple to differentiate. Okay, I'll show you an example later through this logarithmic differentiation. Okay, now the second one says when the power of a function of x is also a function of x. This is very important, remember this. Okay, this one, the power is also x and the base is also x. Example, y equals to x to the power of x. Check this out. If you have y equals to x to the power of x, then I don't have the differentiation of x to the power of x. You cannot use x to the power n, because n means constant, and here the x is not a constant. Remember, you can use in x square, the x to the power n formula you can use in x square, you can use in x cube, but you cannot use in x to the power x. Why? Because this is not a constant, correct? So what do I do in such case? In such case, what do I do is, instead of using that formula, I will use logarithm. So taking log both sides, log y, and this side also if I take log x to the power x, and you know by power rule this will become x log x, isn't it? Now if I differentiate, what is going to happen when I differentiate this? I can apply product rule here. So the power becomes the product now here, because x comes front, because x moves front here. Is that understandable? Okay, so I think solving the sums will help you understand better. Okay, the first sum that I'm going to solve under logarithmic differentiation will be y equals to x to the power of x. So I cannot solve it using normal differentiation, because I don't have a formula for function to the power function. So what do I do? Taking log both sides, BS stands for both sides, correct? So I take log y, this becomes, and this becomes log x to the power of x, correct? Now once I use log, what will happen is the power gets simplified, so this power moves front as coefficient, so x log x, correct? Now what can I do is, I will differentiating both sides with respect to x. I'll say differentiating both sides with respect to x. I will apply the operator. Okay, now this becomes ddx of log y, and this becomes ddx of x log x, correct everyone? Now this part you have to understand. Check this out here. What is ddx of log y? You have to understand it properly. Okay, so now what is ddx of y? First of all, you tell me. Ddx of y is dy by dx, isn't it everyone? Yes. And what is ddx of log x? Ddx of log x will be 1 by x, isn't it? Though you may say, you may apply chain rule in any normal function also. So you may say ddx of log x is 1 by x. Again, if you do ddx of x, then what is going to happen? Ddx of x is 1, so no need to write. That's why we always have ddx of log x as 1 by x. But when you have ddx of log y, what are you doing is, you are differentiating a function of y in terms of x, isn't it everyone? Check this out. This is x. You are differentiating here. When you do ddx of log x, That's differentiating a function of x in terms of x. That will be 1 by x. Quite simple, isn't it? But when you are doing ddx of log y, let me show you again. When you are doing ddx of log y, ddx of log y, then you are differentiating a function of y in terms of x. So what will happen? Chain rule will be applied here, remember. So what is ddx of log y? So ddx of log y, imagine this is x, imagine this is x. So ddx of log, what would be the answer if it was ddx of log x? 1 by x. So I will write 1 by y. There was a y here, correct? But into, I have to do chain rule, then ddx of y also y. So finally it will be 1 by y dy by dx. So whenever you differentiate a function of y in terms of x, okay, then dy dx will be attached, you may say that. Okay, an example, another example will be, what is ddx of sine y? Just an example. You know, ddx of sine x is cos x, so, but ddx of sine y will be cos y, okay, because it will be in terms of y, but dy by dx will be attached here. Why dy by dx? Because it follows chain rule. First I will do only sine, then I will do y, because you are doing a function of y in terms of x. What about a ddx of cos y? It will be minus sine y, isn't it? That is the normal derivative, and dy by dx will be followed. What about, let me show you some more. ddx of e to the power y, it will be e to the power y as normal derivative into, what is ddx of y? Then dy by dx. So every time you differentiate a function of y in terms of x, this dy by dx will be attached, correct? Okay, so let me show you something else also. What about what about if you have let me say ddx of e to the power z, then suppose instead of y. Again, this is also the same concept. You are differentiating a function of z in terms of x, so this will be e to the power z, but it will be dz by dx. Now what will follow? Dz by dx, because you have to again differentiate z as well. So remember, whenever you are differentiating a function of y in terms of x, dy dx will be attached. Why? Because it follows chain rule, correct? Okay, so now once you have understood that, let's come here. So what is ddx of log y? It will be 1 by y followed by dy by dx, correct? Okay, that gives me here. Now here I have to apply product rule. Second is log x into ddx of first, that's x, because I see this is the first function and this is the second one, isn't it? Plus first, that's x, into ddx of log x, correct everyone? Did you understand this? This is called the product rule. So finally 1 by y dy by dx equals to log x, and what is ddx of x? 1, no need to write, plus x, what is ddx of log x? 1 by x. So x and x gets cancelled. So finally I need to find this dy by dx. So dy by dx will be, y moves here, y log x plus 1, and finally what is y in terms of x? What was y? Y was x to the power of x, isn't it everyone here? So I will replace it. So x to the power x log x plus 1. So that's the derivative of y equals to x to the power of x. Okay, so understand this one properly, because this is the basics of logarithmic differentiation. Okay, so I can also form a direct formula for logarithmic differentiation. So I'll try to form a general direct formula for logarithmic differentiation. Okay, so what if you have a general question, y equals to u to the power of v. Let's say u is also a function of x, v is also a function of x. Then what did we do in the previous sum was, we used log both sides first, isn't it? We have to use log like this. Then we got a log y equals to v log u. Can I say that? Yes. Then when I differentiate it, so differentiating both sides with respect to x, when I differentiate it, then I get 1 by y dy by dx, you are aware of that, and this side I get ddx of v log u, isn't it everyone? Yes. Now I will get a formula for dy by dx like this. So dy dx will be I can write it down. Okay, y d dx of v log u. So this is the formula for this one. So this green one, you may copy this formula, direct formula. No need to copy how did you reach this, but I just want you to copy this formula. This is the direct formula for logarithmic differentiation. So now how to apply this formula? Let me show you the same sum that I have solved earlier. I had solved in a long method, you may say that. Okay, I have solved it in a primitive way by using logarithm and then simplifying it. Okay, but you can also use a little shortcut method to simplify that. Okay, so how would that sum be done? The previous sum I had solved was y equals to x to the power of x, isn't it, everyone? Here this acts as v and this acts as u. Got it? So what will be the dy by dx? Okay, so differentiating directly without taking log, if I say differentiating both sides with respect to x, because I have got the formula now, isn't it? So you may also use this formula. If I differentiate it, I'll get d dx of y equals to d dx of x to the power of x. Got it? And d dx of y means dy by dx. Got it? And how to do d dx of x to the power x? If you ever have d dx of if you ever have y equals to u to the power of v, then what will be dy by dx ultimately? Or you may say y is u to the power of v, isn't it? So sorry, I may a little, let me change the formula a little. So this is dy by dx, but dy by dx means what ultimately? Let me show you here. So d dx of y means u to the power v equals to y d dx of, not y, u to the power v d dx of v log u. I can write this. Okay, remember, instead of the green highlighted one, you better copy the blue highlighted one, this one. Okay, this would be the right formula, correct one. Okay, so d dx of u to the power v equals to how much, everyone? U to the power v d dx of v log u, if you ever get that. So this looks like u to the power of v, and I've already separated the u and the v, I know. So this acts as u and this acts as v. Here in this case, u is also x, v is also x. So how to do this? D dx of u to the power v will be very easy. Directly I can write x to the power of x, that's u to the power of v, open bracket, v log u. V log u means x d dx of d dx of log x, like this, correct? So directly, because see this, isn't it, everyone? So u to the power of v d dx of v log u. So I have done the same. So here u to the power of v d dx of, sorry, my mistake, d dx of, I'll have to write here d dx of v log u. That would be correct, sorry. Okay, is that correct? So make corrections. So that's how it is done. So what will be the answer? Let's do it directly. So the answer will be x to the power of x, and you know d dx of x log x is how much? So product rule, that is log x into d dx of x, second into dx first, plus first into d dx of second. And what do I get here? I get x to the power of x log x into 1, no need to write, plus x into 1 by x, cancel, and the answer is x to the power x log x plus 1. Careful observation. So did you understand this? I could have done this directly as well. I think I have done the same answer we've got here, x to the power x log x plus 1. And what did we get here? We got here also x to the power x log x plus 1. Okay, let me give you another example of a direct formula. How would you solve this? I will do it by both the methods, whatever you prefer. Okay, so I'll show you both the methods of doing this sum. You can just see which one you prefer. I think the shortcut will be more easier actually. I'll help you understand why shortcut formula would be more easier. Okay, in what cases will you use the shortcut formula? Correct. Okay, so first let us do this by the primitive old method, that is using logarithm both sides. You see, I have base also, the base is also in terms of x and the power is also in terms of x, so I cannot differentiate this, so I'll have to use log. So using log both sides. So what do you get? Okay, I'll get log y equals to log sine x to the power log x. Correct, everyone? Now this will be log y, and the power law, this log x will come here. So log x log sine x. Remember, one more log. Correct? There's a small multiplication sign here. Now differentiating both sides with respect to x. Correct? what do you get? I get d dx of log y equals to d dx of log x into log sine x. Correct, everyone? Okay. Now this becomes 1 by y dy by dx. You know, the chain rule will be applied here, and then here product rule. Okay, how this acts as a first function, this acts as a second one. So okay, let me show you in different shades. Red, not red, blue and green. Okay, so this green. Now, so d dx of log x into log sine x will be product rule. So how does the product rule work? Second would mean log sine x, that is the green one, into d dx of log x first, okay, plus now the first and d dx of second, and that would give me log sine x. Correct, everyone? Check this out. How? This first into d dx of second, second into d dx of first. Correct? Okay. That gives me 1 by y dy by dx. And here, what is d dx of log x? 1 by x. So log sine x into 1 by x plus log x. And how to do d dx of log sine x? Chain rule. That's why chain rule is very, very important. It is applicable inside logarithmic differentiation also. So imagine this to be x. So what is d dx of log x? 1 by sine x into d dx of sine x, cos x. Correct? First I need to do log, then I need to do sine x. Okay, I have done it directly. Now 1 by y dy by dx equals to 1 by x log sine x. Can I write like this? 1 by x, I'm bringing it right in front, plus cos x by sine x means cot x. So cot x log x. Correct? Because this two is different from log x. I can't multiply them. Okay. So finally the answer, dy by dx equals to y log sine x by x plus cot x log x. Okay, and what is y? Everyone knows it. Y means sine x to the power log x. So sine x to the power log x, and whatever you have in the bracket, that's log sine x by x plus cot x log x. So it's quite complicated. The answer looks quite complicated, but that's the simplest form. Okay, so remember, logarithmic differentiation is quite tricky. Try to understand it properly, take your time, and then copy this sum. If you don't get it in one time, you just repeat the sum and watch it over and over again. Got it? Now I will do this same sum. The same sum I have shown you by the little lengthy method, I may say, by using logarithm, differentiating, etc, etc. I've just created a formula here. That's the formula, isn't it, everyone? So what is d dx of u to the power of v? It's u to the power of v d dx of v log u. Isn't this the formula? Let me write it down here. The formula is d dx of, if you ever have d dx of u to the power of v, then I can say u to the power of v d dx of v log u. That's the formula, isn't it? I will do the same sum by using the formula. Let's see how short it becomes. Okay, so the question was y equals to sine x to the power log x. Correct? Now what do I do here? d dx of y equals to directly d dx of sine x to the power log x. Here I didn't use log both sides because this is a direct formula, I know. So I've just differentiated both sides with respect to x. So this gives me dy by dx, and you know the direct formula. What is d dx of u to the power of v? So doesn't this act as u and this act as v, everyone? Yes. What is the formula, everyone? d dx of u to the power of v. It's u to the power of v. That's sine x to the power log x. First of all, u to the power of v, writing in the same format, into d dx of v log u. V is log x, and log u means log sine x. Correct? So I'm getting the same thing only, isn't it, everyone? See, I've got the same thing here also, d dx of log x into log sine x. So what is the differentiation of this? No need to do it. I will not do it again. What is d dx of log x into log sine x? Ultimately, the one which is inside the bracket. This is the differentiation of d dx of log x sine x. So ultimately, what do I get? The answer, I'll directly write sine x log x, and we have already done this product rule. We have already used this product rule. We have done this here, isn't it, everyone? This same product rule here. This is the one. So directly write the answer. So okay, let me move it a little. So sine x to the power log x, and open bracket, open bracket, what is the derivative of this one? The derivative of this one is log sine x, if you remember from the previous one, x plus cot x log x. I will get the same thing because the derivative is the same, this one. So I'm getting the same answer. Check it out. Sine log x, log sine x divided by x plus cot x log x, and here also same thing. So see how short does it become. This is directly by using the formula, this is by using logarithm and following the long procedure. Okay, so now where will you use this? So it's okay if you want to do this sum directly by using the formula, it's not a problem, but especially you will use this when two logarithmic differentiation type of sums are added or subtracted together. Okay, so the next sum I'll show you that. Okay, so this would be the best sum where I can show you why direct formula will be easy. Okay, suppose if you had to do this sum by using logarithm both side, or by you may say the long method, then what you need to do is you need to differentiate these two functions separately. You may say let u equals to x log x and v equals to log x to the power x. You may have to take it out differently, okay, and then differentiate this separately, differentiate this separately. You will get the answer du by dx for this one, and for this one you'll get the answer dv by dx, and ultimately whatever you answer you get here, you just have to add it up in the end. Okay, that will be the final answer, because that way y will be u plus v, and then dy dx will be actually equals to du by dx plus dv by dx. That means whatever you get du by dx and whatever you get dv by dx, just add it up here, you will get the answer. Question mark plus question mark, you may say that, whatever you get. Got it? So by differentiating it separately. So that is when you need that is if you have to do it you may say by taking log without using the formula. Okay, the you may say the long method. Okay, but if I want to do it in a little shortcut method, then I can use the formula. Instead of taking this out and doing this separately, instead of taking this out, u and v out, instead of differentiating these two separately, what I can do is I can differentiate them together. Okay, how? Let me show you. Let me rub this first. You can differentiate it together like this, and that will be with the help of formula. The question was y was x log x and plus log x to the power x, isn't it? So now how to do it together directly without taking out, without separating them? This is the best way. So differentiating both sides with respect to x, check this out. This will be quite lengthy. What do I get? I will get dy by dx on the left. This will be ddx of x log x plus log x to the power x. Okay, now I'll get dy by dx equals to, ddx will get separated, ddx of x log x plus ddx of log x to the power x. Okay, now can I not use formula here and here? Because this will act, because this will act as u and this will act as v, this will act as u and this will act as v. So we are doing two sums together, isn't it? So let's proceed. So this will be dy by dx equals to, what is ddx of x to the power log x? The formula is x to the power log x. Remember, let me show you. This will act as u, this will act as v. Okay, so the formula is u to the power of v, this is u to the power of v, into v log u, ddx of v log u. V is log x and log u means again log x. Correct, everyone? Why log x log x? Because v is okay, it's quite dirty. So this v is log x and u is also what? X. So log x into log x. The formula is u to the power of v ddx of v log u. Okay, don't get confused. Correct? Okay. Plus the second one. This acts as u. This acts as u. And this acts as u and this acts as v. Correct? So how to do? Log x to the power x, that is u to the power of v, into ddx of v log u. What's the formula? V is x and log u means log x, because it is v log u. It's v log u. V is x, v is x, and u is log x, so log x. Correct? Okay. Have you understood this? It's quite tricky. Okay, take your time. Now let's differentiate. Let me differentiate it here. X to the power log x. Careful. Now it's very simple. This is a product rule. What is this, everyone? Product rule. Let me show you with a different highlighter. This is first function, this is the second function. Can I do that, everyone? What is ddx of log x, or you can also say log x whole square also, that would be better. Whatever you want to treat it as. Let me do it through quotient rule only. So it will be log x second into ddx of log x again, plus again log x ddx of log x, because both the function is log x, correct? So first into ddx of second plus second into ddx of first is the same thing here. Log x to the power x, and how do you do this? Here this is the first function and everything is the second one. Okay, so second, it will be log x into ddx of x, plus second, that's log x, sorry, first x into ddx of log x. Okay, so again I repeat, second into ddx of first, first into ddx of second. I think that makes sense now. Okay, now let's differentiate. It will be x to the power log x and 1 by x log x here, as well as here 1 by x log x. So plus log x to the power x, and what happens here? This will be log x, because ddx of x is 1, plus x. What is ddx of log x? First imagine this is x, so it will be 1 by log x. I will do the outside log first and then the inside. What is ddx of log x again? 1 by x. Okay, that gives me x to the power log x. 1 by x log x plus 1 by x log x is the same thing, isn't it? So it will be 2 by x log x. I can write it like that, and plus log x to the power x, and you get here log x, and I think I can cancel this x and this x, so it will be 1 by log x. So that will be the answer. Check it out. Okay, so that's how we do it directly by using the formula. Otherwise this sum would have been quite lengthy, because you had to separate it into two parts and do it. Okay, so using the formula makes a logarithmic differentiation more shorter. Okay, so repeat this sum, watch it over again to understand it. I know it's quite tricky to solve logarithmic differentiation. So I'll give you some practice sum as well. So this will be the last one. So let's take some time to understand logarithmic differentiation. Okay, I'll give you some simple ones for practice.